Hey everyone, this is the second part of our number 6 solving for an angle, and we're going to use the idea that we can work our calculators backwards with a of our ratios, sine, cosine, and tangent. So when we know the decimals, we can find angles. So we're going to pop into a sheet here, and we're going to talk about this example where we want to solve for angle x. And I'm going to work with x always going to be my angle b today. All the other examples we did last day or in lesson 5 were about finding the side opposite of a. So it shouldn't matter whether we're calling our triangle ABC or DEF or whatever letters you want. We want to make sure that we're identifying though that we're going to solve for x. So again, if I'm going to circle an angle, I'm going to circle my B because that's the side that we're talking about. B is the same thing as talking about angle x. So like we did in the other parts, we're going to make sure we know how to label. Opposite the right angle is always the hypotenuse. Now my hypotenuse doesn't have a number with them. So again, like we just said last time, we don't want him to feel too sorry for himself. So we want to make sure that big C and hypotenuse can be referred to as little c. And here's my angle B. So I want to go opposite of B, which I'm calling opposite of X because we're talking about angle X. Opposite, so the projector screen is shining on 11.5. So angle B or angle X is 11.5. And because there's only 3 sides to a triangle, once you know hypotenuse and opposite, we know then that the adjacent side to angle X, the adjacent to angle X is 6. Now, we're going to do a little extra work again on our examples. I really think that as we're learning about sine, cosine, and tangent, I think it's important for us to actually write down all 3 of the ratios. We don't need all 3 of the ratios, but we're going to write all 3 of them down. It's kind of like solving a puzzle. Sometimes if you can put more information into the puzzle to begin with, it makes solving the puzzle a little bit easier. So angle x then, sine of x, cos of x, and tangent of x, just like when we're solving a side. Let's write the ratios out. And then let's fill in the numbers and the letters that you know for sine of x, cos of x, and tan of x. Sine of x, opposite over hypotenuse, opposite over hypotenuse, so 11.5 over c. Cos of x, adjacent over hypotenuse. Cos of x, adjacent is 6 over hypotenuse is c. Adjacent over hypotenuse, 6 over c. And then tangent of x, opposite over adjacent. Opposite is 11.5 and adjacent is 6. Tan of x is 11.5 over 6. So when we look at our instructions, we want to be able to label the sides, opposite, adjacent, hypotenuse. We want to be able to write our ratios, sine, cosine, and tangent, and then we want to fill in the numbers that we know. In this case, the numbers and the letters that we know. So now we want to look at our information and figure out which of our ratios is the one that we are going to use to work with. And in this case, there really is only one option. If we look at our, I'm sorry about this, going to make this come to the front here again. If we look at our options, sine 11.5 over c, 6 over c, 11.5 over 6, right? This is the only one where we can turn our ratio into these decimals. So just like we did on our earlier skill, we want to be able to take our ratio and work it backwards. So I know tangent ratio is 1.9167. I need to make my calculator go backwards, so tan minus 1 of that, and that's how I'm going to find my answer in the end. So when I go tan minus 1, I should get my answer that x equals 62. So these are the steps I want us to go through on our 3 examples. Label the triangle, hypotenuse, opposite, adjacent. Again, and that's all relative to angle x. Write the ratios, sine, cosine, and tangent. Figure out which ratio is the one that turns into a decimal ratio, and then tell your calculator to work backwards, tangent minus 1, cos minus 1, sine minus 1, whichever one it is that works for the ratio to get your answer. So let's do that now for the next question. I guess it's going to be question number 3. So again, we're going to label relative to angle X. Angle X I've called B again. I want to label hypotenuse. So 90 degrees projects over here to 5.3. That's perfect. But hypotenuse has a number to be with it. Here's angle X. I want to project from angle X to the opposite side. So my opposite X is going to be 4.5. And that means then the side that I don't know is the adjacent side. Again, is looking a little lonesome down here. Angle A is projecting, so I'm going to take my little a from angle A and project it down here. So when I talk about my adjacent to X, I know that I can actually fill something in for that. So sine, cosine, and tangent. I'm writing my three ratios. After I have this information, I want to put the numbers in. Opposite over hypotenuse for sine. Opposite 4.5, hypotenuse 5.3. Cos is little a, and hypotenuse is 5.3 over a over 5.3. Tangent, opposite is 4.5 over adjacent is little a. So I write down what I know for information. Again, looking at this, there really is only one option. That's going to give me a decimal. So I'm going to work with the sine ratio this time. So I'm going to take, and I want to change sine of X. I want to go sine minus 1 with my decimals. So again, I want to, circle what I'm going to work with here. And my angle then, sine minus 1 of 0.8491, rounds off to be 58 degrees. And again, I think most of the work you're going to see, it's going to tell us to always round off to the nearest degree. One more example. Circle. There's angle X. I'm going to circle B. Hypotenuse. Opposite 90 projecting across. Hypotenuse is 13. Opposite of B, opposite of X. Here is the projector all the way over here. Looks a little lonesome over here. So because that's B, I'm going to take my little b and put it over here as well. So wherever it says opposite of X in my formulas, I'm going to put little b. And that means the adjacent side to B must be the 7.5. Okay, so I've got my triangle. I've got my ratios. Let's put in the numbers and the letters that we know. Sine of B or sine of X is opposite, so it's little b over hypotenuse, 13, b over 13. Cos of X is adjacent, 7.5 over hypotenuse, 13. Adjacent over hypotenuse, 7.5 over 13. Tangent of B is opposite over adjacent. So opposite is B and adjacent is 7.5. B over 7.5. So again, if that's the information that's given to me, there's only one of these ratios that turns into a decimal this time. So my cosine ratio is this is a decimal. I want to tell my calculator to work backwards. So cos minus 1 this time. And when I go to the reveal, I probably got a little red circle down here as well. Again, just because not good, good. The Goldilocks and the Three Bears again, I think, just right. And my angle is 55 degrees. All right, those are the steps I want us to go through to figure out an angle when you know two sides. Hope that helps, and let's see if you can do some work on your own.